Good morning, good afternoon, and good evening, ladies and gentlemen. This is Glenn Tan speaking. This time, I'm going to talk about GRID Multi VRF, short for GNV, the noise troubleshooting. During this presentation, I will show you the typical noise of the outdoor unit and indoor unit. And also, I will offer you how we handle this noise in China domestic market, just for your reference. And for better understanding and for better listening, I recommend to wear the earphones, and also you need to listen carefully. This presentation divides into these 5 parts. I put the corresponding video linkages at the below description area just for your convenience. Indoor unit noise from the refrigerant flow. Next, we will go to the refrigerant throttle or refrigerant metering noise. It is actually the liquid and gas refrigerant flow noise in cooling mode. First of all, I will show you the noise example just for your reference. Just like this. Let's hear again. And we will hear another time. And please pay attention to the shrak, shrak, shrak. This is the noise. Okay. And also you can find that this noise is just similar to the boiling water or the inside water or liquid just scratching the pie, right? And here I'd like to explain why and how this noise coming out. And as you know that for the VRF system, in cooling mode, the refrigerant is metering at the indoor unit EXV, which is just metering inside this indoor unit EXV, and before that it should be completely liquid. And then when you get metering, then it will become the liquid and vapor, which is the refrigerant gas and liquid mixture. And then you go to the indoor heat exchange to make heat exchange, which is doing cooling. And we need to ensure this part, the enter refrigerant, it should be completely liquid. And what is the benefit we can get from to make it to be this 100% liquid? It is that when we do the metering, it will make the process to be peaceful, and also from the noise, it will make it to be also very low. And in opposite, what is the consequence? If we cannot ensure it is 100% liquid, it is that it will make the process to be turbulent. Also from the noise, it will be very loud or significant. You can just consider that if you would like to drink a Coca-Cola, before you drink it, if you shake it a lot and then just open the cap, what's the sound you will hear? Sha, right? And this sound is very similar to this boiling water, right? And that is the reason why it comes out. And also, we also test in our sound lab. This is with the liquid and gas noise for the green color curve. It is the noise frequency spectrum, and this is with sound, which is ensure it is 100% liquid when you're doing the metering. And we find that here is this is different, and also just due to here, which is 1000 to 300 Hz, the frequency spectrum, it makes the noise. And as we know this reason, and also our countermeasure or solution is very simple. And first of all, how to identify this one? It is that you need to change the indoor unit, your problem indoor unit, from cooling mode to air supply mode. And then if this noise just disappear, so you can convert it, right? And this solution is just ensure the outdoor unit subcooling degree, which is to ensure the liquid out from the outdoor unit, it should be low enough. And here is a case, and you can find it, verify this complaint. So our serviceman is going to the site and also repeat the noise. And from the data, we also record it and we find that the outdoor ambient is 37. Indoor room is about 24, and it is a 12 kilowatt GMV minute with only 2 indoor units. And our serviceman just turned on 2 of these indoor units with high fan speed. The set temperature is 16 degrees, and we find that after just turn on 15 minutes, there is some boiling water or boiling from the indoor unit 2, which is this one. And here is the system diagram. Inside the green color, it is the outdoor unit, and this part is the indoor unit. So at the outdoor unit here, I will show you how the refrigerant flow in the cooling mode. And from the compressor, coming out is high pressure and temperature gas. When it goes through this oil separator, then it will go to this four-way valve. Then as it is cooling mode, so it will go to the outdoor heat exchanger to release heat. Then the gas will become liquid. And at this ESV1, which is the heat tank ESV of the outdoor unit, we will keep it fully open to make the refrigerant to flow through and then cool the subcooler. And at this part, you can also find that a partial refrigerant will get through this ESV2, which is the subcooler ESV, and get expanded. Then it will become low pressure and temperature. So we make this part to absorb heat from the main load. Then the main load will become cooler, and which we can get the temperature here. And then this part, a partial refrigerant will become from liquid to gas, then flow back to the gas liquid separator. And as the main load, so it will become cooler, and then it can flow further, which is to the furthest one. And at this case, it is the number 2 indoor unit. It is the furthest one, and then it make exchange inside, and before that it will get expanded at this indoor unit ESV, and then become low temperature and absorb heat, which is doing cooling, then become gas and flow back to outdoor unit, then to gas liquid separator. And the problem for here is this indoor unit 2, which is also the furthest one. So here is the refrigeration cycle, and we will analyze the data. So first, if we check the compressor discharge temperature is 94 degrees. Actually, it's a little bit high, but still okay. And how about the high pressure and the subcooler degree, which is this one and this one. So we can get the subcooling, which is 53, substrate 45, it will become 9 degrees. Actually, for this one is this is the problem, as what we require from our control is at least it should be 15. So at this one, we need to check the subcooler, which is the subcooling degree, this one, and also the ESV opening. So we find that it is okay, and also the low pressure. But the ESV opening for this one is actually too much. So how about the indoor unit pressure and the temperature and the ESV opening? It's just like this. From this data, we find that it is still okay, all within desired range. and as the noise is still continuous, so we can find that our conclusion is the refrigerant not enough, maybe leakage, or uh, at the installation stage there's not charge enough, and the refrigerant cannot maintain the liquid state when we get to the furthest indoor unit, which is here, and also leads to the noise. And after we have this conclusion and we charge our serviceman, charge additional 300 gram, this problem cleared. Here is another case. It is 16 kilowatt GMV minute with 5 indoor units. And the outdoor ambient is 30 and indoor room temperature 27 degrees. This time we will turn on all indoor units with high fan speed and setting temperature 16. And we find that from the installation, the indoor unit 3, which is at the middle, this one makes the noise. And here is the phenomenon. Let's hear the noise. Just like this. Okay, so let's summarize the phenomenon. We just turn on the compressor for cooling, but the noise will comes out and becoming loud gradually, and especially when this phone or the microphone, which is close to the air return, will become significant. And also we change it to air supply mode, and this noise disappeared, which means it is the refrigerant flow makes the noise, right? So with this one, it is much easier to analyze and to do the solution. And also we record the data just for your reference. We turn on the system and operate for 15 minutes at least. Then we put the data inside the cycle diagram for analyzed. So first is the compressor discharge. Okay, within our desired range. And then to check the subcooling. High pressure 42, subcooling liquid out 24. So we get it. Subcooling degree is 18. Also okay, within our desired range. And also we double check the subcooler ESV opening and the gas out, and also the low pressure. Okay, within our desired range. And also the indoor unit temperature, which is the pipe in, pipe out, and also the ESV opening, also within our desired range, which means from the data, it seems okay. So we can eliminate the reason for the low subcooling degree leads to this noise. So we will make a detailed check of this indoor unit 3. We just inspect this indoor unit and find that this is the picture we took from the this indoor unit 3, and we find that this is the EXV body, which is already covered with the damping gun, and it touch the first is the water pan, and then also touch the panel. We find that with the cover of the damping gun, even the refrigerant expanding process is a little bit turbulent, but it is okay because it has been covered. But if we touch with the parts, it will be transmit the noise out and also amplify. So the countermeasure for this one is we shade the EXV to not ensure not contact with any parts of it, especially for this two. And after this one, this noise is also cleared. Next, also the refrigerant system noise, but this time is not the EXV, but also the other components squared. And the phenomenon is similar. First is no matter it is cooling mode or heating mode. And next is just after you turn on the compressor, the noise comes out and it will become loud or significant gradually, and which means the refrigerant flow and the noise coming out. And the last is how to do the identification is you can make this indoor unit from cooling or heating just to air supply mode, and if this noise disappear, then you can convert. And also I will play an example for your reference, just like this. You can hear the duck duck duck. It is the noise. And how it comes out, it is that just during the operation, the refrigerant flow just impact with the components and also including the EXV, but this time it is the distributor and filter, and this will make the noise. And but also this noise is not that easy to transist out as we covered by the damping gun. So first is we need to identify which is the noise source, and also need similar to the EXV. First is to check the subcooling degree, whether it is enough or not, and if it is not enough, always due to the EXV, it will make the noise, and you can just follow the previous instruction to check. Except the EXV, there is also the distributor and filter inside the indoor unit, and these two makes the noise. And how to identify is you can just follow this one. You can find that this serviceman just apply the screwdriver. One end just touch this distributor, just like this, and the other end just to touch his ear. This method is to identify whether this noise is coming out from this distributor. If the noise from the distributor, in this case, it becomes most significant, then you can convert that this noise is coming out from here. So the next is to do the solution to how to cover it or how to handle this noise. But first of all, you need to identify where is the noise coming out, which component. As we already know the reason why this noise coming out, the solution is also very easy, as we cannot stop this refrigerant flow as you will doing the cooling or heating. What we can do is just to cover or to lower this noise. So the first solution is just cover by the damping gun, just like this. And the other is maybe this distributor or this filter is clogged, just like this one. You can find it. It is clogged, and also this makes the noise. So the solution of this one is just replace this distributor. And then the next we'll go to the heating off indoor unit. This heating off including the thermal off, which is we reach the setting temperature, the indoor unit will turn off. And then the next is original off, which means it's not turned on. And so first I will display the noise for your reference, just like this. Also very similar to the cooling mode, right? But the noise is not that high. But however, you need to notice that this is the thermal off or the turn off, which means the indoor room is quiet. especially when you're going to when you sleep, it will be very quiet, and this noise happens, it will make it to be annoying. So, and the reason is that the refrigerant impact with the ESV body and also makes the noise. So you may wonder why the indoor unit already off, why still there's some refrigerant just also flows through. And the reason is that even it is off, and just like this diagram, also you can find that here is the outdoor unit, here is the indoor unit, and the refrigerant come from the compressor will flow to the indoor unit first, and then they become liquid and flow back to the outdoor unit and get expanded here. And this is almost the same. And the problem is if it is turned off. So let's assume that this one is the turn off indoor unit. If we turn off the indoor unit EXV fully closed, what will happen? And as you know that the gas is still hot, and even it is not turned on, but it is the temperature of the uh, refrigerant is still higher than the indoor room temperature, right? That means it will release heat, and if we release heat, it will also become liquid. And if this is fully closed, just like this, and sooner or later it will make all the refrigerant to become liquid, which is occupy all the area of this heat exchanger, which means more and more refrigerant will become liquid in this indoor unit, and sooner or later it will not enough refrigerant for this, which is turned on the indoor unit operate, which means the system will short off the refrigerant. This just due to we turn off this one. So in conclusion, even it is turned off, we still make this indoor unit ESV at a low pulse to make sure the refrigerant still goes through of it. So, and we know that why we need to get it open, and also just due to its open, the refrigerant impact with this EXV body and makes the noise. Here is the countermeasures. First, we need to check whether is there any contact of the indoor unit, especially the ESV, with any part of the indoor units. And the next one is we need to use the P40A, which is to change the off indoor unit ESV opening. And here is the password how to enter this P40A. And also, just like what I have right here, this is the minimum ESV opening of the off hitting off indoor unit, and this is only available to hitting off indoor unit. And actually, the default setting is about 50. And when we change this one, it will make the minimum ESV opening to the value you set. And then this may just improve the noise. And also we recommend this value to lower than 100 pulse. Otherwise it will make too much refrigerant to go through this. And the last is maybe the refrigerant amount is not enough or has leakage. Refrigerant throttle or metering. This time we go to talk about the oil return noise. First is the phenomenon. The first one, it is low compressor RPM operating. It is especially in part low condition, which means you just turn on 1/3 or 1/4 of the indoor units, and maybe you just make the system just under the low condition. For example, the outdoor is already, for example, 23 or 22 degree, and you also need to turn on for cooling. Then the system will operate in part low, which means the compressor is in low RPM. And the second part, it is periodically occurs, which means it can repeat but the period is not fixed. About 4 to 8 hours it will come out again, and the last period is about 3 to 6 minutes. This is for the oil return. And the last is no matter the indoor unit is turned on or turned off, it will make the noise. And then next we will talk about why we need the VRF for the oil return. As you know that for the VRF, especially in part low condition, we also need will output the oil from the compressor, which on this diagram we output the oil from here, and then this is in cooling. Then we offer to the outdoor heat exchanger, and then to the indoor unit, and the oil and the refrigerant mixture we just make heat exchange here, and the refrigerant will become gas and flow back to the outdoor unit. It's okay, but the oil, it is still remains at the indoor unit heat exchanger, which is at this part. The purple is the oil. And the oil return is the target is to make this oil to flow back to the outdoor unit and also just to here, gas liquid separator. And how to do it is just we will hire the compressor RPM, which is higher this one, to apply the high refrigerant flow rate to push or to flush this oil to back to the here. So in the oil return period, outdoor fan is still operating. The indoor unit, especially this EXV, this EXV1 fully open. You can consider this oil return to be the defrost or the cooling is fine. But the indoor unit EXV, either it is on or off, it will open. Do you know why we need this one? All indoor units. The reason it is that is the compressor is high RPM, also indicates the refrigerant flow rate also very high. So we need to make all of them to open to allow the large refrigerant flow rate to go through. And this refrigerant, if you impact with this indoor unit EXV, and also it makes the noise. And if this indoor unit is turned off, which means there's no the other noise to cover this impact noise, and also it makes this noise to be significant. So I will show you how the oil will flow inside the oil return period, just like this. You can find it. We just make the refrigerant to flush this oil to back to the gas liquid separator. Then it can offer to the compressor for lubrication. So the reason why this noise happen, it is this one. Refrigerant impact with the EXV, impact with this one, and for the off indoor unit and the heating in indoor unit, the fan is turned off, and which means there's no the other noise to cover this noise. Then we make it to be significant. And the last is if these components, if it touch with the panel, it will amplify this noise. So the solution for this oil return noise is actually not very good one. You can just charge a little bit refrigerant. This just may improve this noise, but it is impossible to eliminate. So it is very important to tell or to explain to your customer the reason why this noise happen. That's all for this part of the presentation. If you still have any other question to ask or to discuss or any suggestion, please feel free to contact me on my personal email address.